Hi everyone, the next video is applications video number 3, and it deals with problem types extremely similar to worked example 4.11 on page 118. I'm not going to do that because you've got that there as a reference. What I'll do is I'll do a couple from exercise 4E. So I might just start with 4E question 1, and I'll just do the first one and show you how we use a Maclaurin series. So the problem is this: we've got the limit as x approaches to infinity of sine x subtract x divided by x cubed. Now, I'm just thinking if we apply L'Hopital's rule in this case, because we have 0 and 0, we could use L'Hopital's rule in this case, but we're going to use the Maclaurin series to evaluate this. And I think you can probably all see the answer if you apply L'Hopital's rule, but we're going to use a different technique in order to do that. So again, because you're going to use L'Hopital's rule, it's probably not going to be that popular of a question should it pop up on the exam, because there's a much easier way to solve it. Okay, so let's just get to it and solve it. So basically, let's got the limit as x approaches to infinity. Let's use a Maclaurin series here for sine, which is x minus x cubed on 3 factorial plus x to the power of 5 on 5 factorial. So there's my sine x there. Then what I'll do is I'll subtract x, and I need to divide by x cubed. So that's going to equal to the limit as x approaches infinity. We can eliminate that x, and we can divide by x cubed. So what I'm left with is minus 1 on 3 factorial plus dividing by x cubed will give me plus x squared on 5 factorial. Take the limit now as x approaches 0, and we end up with minus 1 on 6 plus 0 dot 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 in that case, because they'll all be 0. These other terms all here will all have some x in them, and of course they'll all just approach 0, 0, 0, and so on and so on. So we end up with that's minus 1/6. That's a relatively straightforward one. So what I'd like to do is go to the another one. Look, these are all pretty easy. So that's problem from 4E question 1. I might go down and do another one. I can see here we've got this one, question 3. I might just quickly look at question 3 again on the same page, page 119. And let me just show you how to do this one. Find the first 3 terms of the Taylor series for sine x minus 3 for that Taylor series about the point x equals to 3. And then we want to use that Taylor series in order to find this limit of x squared minus 9 divided by sine x minus 3. Okay, so first of all, we've got to form the Taylor series, so we'll do that. And then once we form the Taylor series, we can replace that expression there with the Taylor series. So let me do that. So about the point x equals to 3. Okay, so we've got f of 3 will be equal to sine 3 minus 3, which is sine of 0, which equals to 0. Let's go f dash x will be equal to cos x minus 3, and so f dash 3, because it's a Taylor series, will be cos of 0, which is 1. Let's do the next one. F double dash x will equal to minus sine of x minus 3, and of course f dash 3 will be equal to 0. F triple dash x will equal to minus cos x minus 3. F triple dash 3 will equal to minus 1. And you can probably see here, I've got that one there, that one there. The next time I'm going to get 1 will be f5, 3, and that will be equal to 1. Okay, so just hang on for a moment. I'll just pause that. I've just got a call. Okay, so I think I'm back again. Yep, back again. So we're just forming a Taylor series here, and we've just found that there. So my Taylor series for sine of x minus 3 will be f of 3, which is 0, and then the first time that we have this is 1, so that will be x minus 3, because it's about the point x equals to 3, and then the next time will be minus x minus 3 all to the power of 3 divided by 6, and then the next one will be plus x minus 3 to the power of 5 divided by 5 factorial, which is 120. Okay, so there's the first part that they've actually asked me to do, which is just to express that there as a Taylor series, which I've done. Now we need to use that Taylor series in order to find this limit here, which is part B. So I've just done part A, and this is part B. So let me just shrink that down and stick that over there, and do the next part here, which is to find the limit. So I've got the limit as x approaches to 3. What I'm going to do with this bit here is split that up as a factor. So I'll split that up as x minus 3, x plus 3. And as you can see, I could factorise out one of the x minus 3's from each of this expression, which is what I'm going to do. So I'm going to factorise out x minus 3. That will leave me with 1 minus x minus 3 all squared on 6 plus x minus 3 to the power of 4 on 120. And I can cancel that out there, and I can cancel that out there. Okay, now as x approaches 3, so we'll just simplify this a bit. This is now the limit as x approaches 3 of x plus 3 divided by 1 minus x minus 3 all squared on 6 plus, and I won't do the rest of it because, of course, when we put 3 in here, that's just going to become 0. So let's now take the limit. So on the top line, 3 plus 3 is 6. And on the bottom line, I've got 1 minus 0 plus 0, because all of these terms here will just be approaching 0. So those additional terms there will simply be approaching 0. So my answer will just be equals to 6. Okay, so that's the third type of application. I've got one more application to do, and that will finish off that option on calculus.